Hello everyone. Now coming to with our continuation of lecture, we have finished the continental drift theory and the seafloor spreading theory. Now coming to one of the most important theory of the geography, that is the theory of plate tectonics. What is the theory of a plate tectonics? The theory of plate tectonics is based on the idea that Earth is cracked at different places. I told you to imagine Earth like an boiled egg. Now consider this Earth, this boiled, the topmost shell of an egg being cracked at different places. Same thing you can apply it to the crust. The crust of the Earth is not a uniform covering over the Earth. The crust of the Earth, we have already done that. We divide the crust of the Earth into Sial, into Sima, or the recent view into the continental crust and the oceanic crust. And now even this continental crust and the oceanic crust is not uniform. It is having cracks at different places because they are the cracks, because they represent the zone of weakness, because they represent the zone of upwelling of the convection currents, because they represent the zone where there is a cracking, where there is a volcanic eruption in the surface of the Earth. So based on this, we can say it based on this concept that the Earth's crust is cracked at different places, and the topmost layer, the solid blocks on the Earth's crust, which are known as lithosphere, this lithosphere glides or slides over the asthenosphere. We have the basis of the theory of plate tectonics. So what is a plate? We will define the plate properly based on we will again define the plate, the concept of a plate again, but the plate theory of a plate tectonics is based on the idea that the Earth's crust and upper mantle are broken into sections which are known as plates. They move around the mantle, or we can say they move around on the weak asthenosphere. So what move around? The solid blocks of the Earth's surface, the solid blocks or the solid slabs on the surface of the Earth are known as plates, and these plates, which are cracked at different places, they move on the weaker zone of the Earth's surface, which is known as asthenosphere. What is the meaning of the word asthenosphere? You remember your previous lecture, astheno means weaker, sphere means zone. So the weaker zone of the Earth's surface is known as asthenosphere. Now what is the asthenosphere made up of? As you can see in this diagram, the asthenosphere is made up of topmost layer of the mantle and the lower layer of the Earth's crust. So the topmost layer of the mantle and the lower layer of the Earth's crust is the asthenosphere, while the lithosphere, again the part of a crust and the upper mantle, is the lithosphere. So these lithospheric plates move on a weak plastic-like, or we can say a jelly-like asthenosphere. How they move? The weak plates, which plates? Lithospheric plates, glide over the weak asthenosphere, giving rise to different geographical phenomena, which is explained by the theory of plate tectonics. So remember the concepts here. What is a lithosphere? Lithosphere are solid slabs, which are solid slabs on the surface of the Earth. Asthenosphere is a weak jelly-like substance. On this weak jelly-like substance, the solid slabs move around or glide around. This is explained by the theory of plate tectonics. But how did the theory of a plate tectonics actually develop? Is this theory credited to a single person, or was this theory a new idea, or was it development of some old idea? Now we have already done continental drift theory, we have already done the seafloor spreading theory. If you remember the continental drift theory was given in around 1912 by Wegener. In this continental drift theory, which was given by Alfred Wegener, Wegener said that Earth was initially made up of a supercontinent which was known as Pangaea. This supercontinent Pangaea was surrounded by a super ocean which was known as Panthalassa. Over the period of time, the Pangaea broke into Laurasia and the Gondwana land. I won't go too much into detail because we have already discussed this theory. This Laurasia land was further broken down into North America, Europe and Asia, while the Gondwana land further broke down into South America, Africa, Indian plate or Indian peninsula, Australia and Antarctica. So there was further breaking down of this initial phase when the Pangaea broke down into Laurasia and the Gondwana land. The intervening space was filled up by a sea which was known as, remember, Tethys Sea. This phase is known as opening up of the Tethys, and then the further there was breaking down and the drifting away of the continents from the original place. The North America drifted westward, South America drifted westward, and as a result, space between them opened, which was filled up by the Atlantic Ocean. Indian plate drifted to the north towards the Eurasian plate, and as a result, the space was filled up, which was known as Indian Ocean. Due to the drifting of the Indian plate from here towards this region, the area of the Tethys Sea was reduced, and overall, the change or the drifting of the continents continued till the present day position of the continents has been achieved, as in the last figure. So we can say that we have formation of the present day continents as well as the formation of the present day oceans. For example, Atlantic Ocean is due to the westward drifting of North and South Americas, that is both the Americas, from Europe and Asia. Pacific Ocean is an example of a contracting ocean because it was original Panthalassa which was reduced in size to form the present day Pacific Ocean. Indian Ocean was formed due to the northward drifting of Indian plate towards the Eurasian plate, and the remaining Tethys Sea, what we call today Mediterranean Sea, is just nothing but the remaining part of an Tethys Sea. If we look at the animation here, which is little bit fast, you can see that initially there is a supercontinent known as Pangaea, and the continents were drifted to occupy their present position. In this figure, we can see the focus is here on the Africa in this animation, that the present day continents. If you can see that the Pangaea, then after that Pangaea, Laurasia, Gondwana land further broken down, South America drifting away, opening up of the Atlantic Ocean. India, which is seen in the left hand, in the right hand corner down, it is going upwards towards the Eurasia region. So you can see in this region, and thus we have present day formation of the continents. Even the continents are further drifting, but what Wegener could not tell was a proper force of drifting. What was his force? He said that it is a gravitational force. It is the rotational force of the earth, gravitational force of the earth, and the tidal force. Obviously these forces are not that strong enough. You know, gravitational force is one of the weakest force in physics. So these forces are not that strong enough to cause drifting up of the continents. So, but the Wegener, there were evidences to prove the Wegener's theory were right. We have already done whatever the different evidences. So, example, jigsaw fit of the continents, distribution of fossils, formation of same kind of rocks, same kind of mountains across the continents, then placer deposits, etc. And based on this, there were some of the mapping done while laying down of the telegraphic cables. They found that there is a continuous mountain chain which is existing below the ocean floor, which gave rise to the third theory, which was known as sea floor spreading theory. The sea floor spreading theory was given by Harry Hess in his concept of sea floor spreading. As you remember here, what happens in the seafloor spreading theory, you look at this third diagram. In this third diagram, below the ocean, what we call as a sima or the oceanic crust, it is opens up. Because of the opening up of the oceanic crust and magma comes outside, it becomes, that is the molten rock material, volcanic eruption occurs. What is a volcanic eruption? Coming out of magma, outpouring of a lava or magma is an volcanic eruption. What is the exact difference, technical difference, we will do in the topic of a volcanoes. What is the exact difference between magma and lava? So the outpouring of magma or lava due to the drifting away of the oceanic crust is known as the concept of the seafloor spreading. So Harry has said that at the center, beneath the ocean crust, there is a continuous drifting away, and thus a new crust is created. Now you see how this new crust is created. This new crust is created due to solidification of the rocks. So igneous basaltic rock is formed. What is an igneous rock? Again, coming to the rocks, we will do in detail, but you remember that the igneous rock is the rock which are formed due to the volcanic eruption. They were the first rocks which were formed on the surface of the earth. So as a result of this, volcanic eruption is continuously occurring, resulting into the formation of a mid-Atlantic ridge. Once this mid-Atlantic ridge occurs, it shifts due to the further expansion of the mid-Atlantic ridge, and the new rock structure is formed. So we will see that these two rock structure are having the same age. These two rocks are of the same age. These two rocks are of the same age, which is shown in the diagram number 1 as the youngest rocks near the mid-Atlantic ridge or mid-oceanic ridge, older rock and the oldest rock. Now, the ocean does not just go on expanding. Otherwise, there will be no space for the continent. So, the new crust which is created has to be destroyed somewhere. So, the crust is being destroyed below the continents, because the oceanic floor, sima, or the oceanic crust, we have already done, is denser than the continental crust. So, when these two come together, the denser material goes below, inside the mantle, and it is destroyed inside the mantle. And thus we can say that the ocean floor acts like a conveyor belt. Or if you remember the ocean floor, if you can relate to the belt on the airport, you remember that ocean floor acts like that airport belt on which your baggage comes. While you can just keep an analogy that continents are baggages, light things which are being carried on that oceanic belt. And as a result, we have the concept of seafloor spreading. So the concept of a seafloor spreading has one of the important implications that it tells us why mid-oceanic ridges are present all around the continents, all around the ocean floor, not around the continents, all along the oceanic floor. And also due to the presence of a subduction zone, there is a destruction of a crust along near the continent margin, what we call as a subduction zone, represented by deep sea trenches here in this diagram. So we have mid-oceanic ridge and the trenches in this region. An example, best example is of the Atlantic Ocean. And so if the question comes in the preliminary examination, what is an Atlantic Ocean? Is it an expanding ocean? It is a contracting ocean. The presence here, our first diagram shows that it is an expanding ocean. Why it is the expanding ocean? Because the South America or the North America, here in the diagram we have shown only South America. The South America or the North America is moving away from Africa and Eurasia. That is, both the Americas are moving away from Africa and Eurasia. Now, again, this was borrowed from the concept of Wegener's continental drift theory. So, though the Wegener's theory was criticized, its central idea was accepted. Led to the seafloor spreading theory, and in between, if we have done the convectional current theory by the Arthur Holmes, because one of the weakest points of Wegener's continental drift theory was what was exactly the force which was required for the movement of the plates. So this force was given by Arthur Holmes as convectional currents which arise from the mantle. As I told you this, remember them, whenever you put anything for boiling for a long time, the steams, the vapors coming can displace the plates. So imagine the temperature inside the earth. It is very hot inside the earth, and as a result there are presence of radioactive materials, radioactive rocks, different kind of rock structures inside the earth. Convectional current rise up. Because they rise up, they start cooling down. After they rising up, they get displaced in different directions, and then they start, because of the cooling down, they again start to subside, and as a result this motion goes on. The place where they rise and drift away is the place where the sea floor spreads, and the place where they cool down and go is the place where there is a formation of a mid-oceanic trench. So this was the concept of sea floor spreading. So the central idea of drifting of the continents, the idea of sea floor spreading, and till today what we can say the acceptable nature of the force, that is the convectional currents which arise from the earth, gave rise to a grand theory, the mother of all theories, which is known as the plate tectonic theory. Now, if the question is which is the longest mountain system on the surface of the earth or on the earth, see, if you look only on the surface of the earth, that is on the continents, Andes is the longest mountain system. But if we look on the total area on the earth itself, the longest mountain system is not present on the surface on the continents, but below the ocean in the form of a mid-oceanic ridge. It is a continuous mountain system which extends below the surface of the ocean floor, which is represented by mid-oceanic ridge. So we can say that the mid-oceanic ridge is formed due to the drifting of the continents. In the real life example, if you look from the satellite, you will see that ocean floors look somewhat like this. So the ocean floor looking somewhat like this, this shows that this is a mountain system. This is a mountain system which has been formed due to the spreading of due to the drifting of the sea floor. So the sea floor here is expanding, and this is a continuous mountain system which is below the ocean floor, which extends from Atlantic to Indian to Pacific Ocean region. So this represents the zone where the oceanic crust is being created. So this represents the zone of a sea floor spreading. And formation of mid-oceanic ridge, which is the, as I say, longest mountain system in the world. So you see, our Earth's surface is very dynamic. There is a constant change going on. Even today, the sea floor is expanding. Even today, the Atlantic Ocean is expanding. Even today, there is a drifting away of both the Americas away from Eurasia and Africa. Even today, the height of a Mount Everest is increasing. Why the height of a Mount Everest is increasing? Because here there is an expansion of a sea floor. If you look at the marker here, where the marker is, there is a continuous expansion of a sea floor going on, and there is a going away of Indian plate below the Eurasian plate, resulting into height of a Mount Everest being increasing. And whenever there is such drifting going on, there are vibrations which set up in the surface of the earth, resulting into earthquakes in this region. So you can see the drifting is going on in this region. This is the sea floor spreading, and these are the continents. Now coming to again to so if the question is explain the development of continental drift theory, or how did the continental drift theory say, you have to tell about the Wegener's idea, and then about the idea of sea floor spreading, and also the idea of convectional currents, which gave the proper explanation. So based on this two ideas of Wegener's continental drift theory, seafloor spreading theory, we have a grand theory known as plate tectonics, which explains each and every geomorphic phenomena, why there is a presence of earthquakes, why there are volcanoes, why there are certain mountain systems all along the globe, because there were some of the limitations of each of this theory which has been cleared by the theory of plate tectonics. Based on your, because we are doing it only for general studies, you do not have to concentrate on the what are the basic limitations. So coming to our first topic, in the plate tectonics theory, what are exactly the plates? See, if you look at the topmost layer of the earth, we can say, we have already said that earth is cracked into different places. So we can say that from the first diagram that the earth may look somewhat like this. It is cracked at different places. So though the gap here shown is for your explanation, it is too large. The gap is not so big in the real world in the first diagram, but the earth has cracks at different places, and this cracks divide the earth's crust into solid slabs, which glides over the asthenospheres. So this Earth's crust, which is cracked at many places, and the solid crustal layers or the lithospheric layers are known as plates. So what are the plates? The plates are solid lithospheric slabs which are cracked at different places. So we can see in the second diagram also, we have South American plate, we have Pacific plate, we have Eurasian plate, we have African plate. So these are the representative, and there is a continuous upwelling, which you don't have to remember the name of this upwelling. There is a continuous upwelling which is going on, resulting into the movement of the plates. So coming to the definition of a plate, what are the plates? We can say that the Earth's crust is cracked at many places, resulting into solid crustal layers of lithosphere slabs, which are called as plates. Now, what is the theory of a plate tectonics? These plates glide over weak asthenosphere These plates glide over the weak asthenosphere, and the resultant motion of these plates and because of the motion reaction, what this plate is known as the plate tectonics. So it is the combination of two words. It is the resultant motion, resultant reaction. What kind of a reaction? Drifting. If they are drifting away, then it will give rise to the seafloor, mid oceanic ridge. If they are coming together, it will give rise to mountains. It will give rise to earthquakes. So this resultant motion, this resultant So we will see that the Earth's crust is cracked at many places. The solid layers of the lithospheric slabs are known as plates, and the resultant motion of these plates, that is, what are the different types of motion which we are going to study in the theory, and the reaction which is caused is known as plate tectonics. So what is the plate tectonics? Plate tectonics is the motion and the reaction of the plates. Now these plates are classified. So if we look here in the first diagram, we will see that this in the Pacific plate is generally blue in color. Why is the Pacific plate blue in color? Because it is mostly made up of oceans. South American plate is brown in color. Eurasian plate is brown in color because it is made up of continents. So the plates here can be classified into, the plates here are classified into oceanic plates and the continental plates. Now, what are the oceanic plates? The oceanic plates are the plates which are dominated by the oceans, while the continental plates are the plates which are dominated by the continents. So the oceanic plates are largely made up of oceans, oceanic crust, while the continental plate is largely made up of continental crust. And based on this, we have different kind of motions, different kind of reactions. Now again, our previous knowledge will tell us that the oceanic plate is denser as compared to the continental plate, which is comparatively lighter in So the Earth's crust, we define the plates into the oceanic plates and the continental plates. To give you an example, one of the best example of an oceanic plate is the Pacific plate, is largely an oceanic plate. Eurasian plate, that is Europe and Asian plate, is largely a continental plate. So we have the oceanic plate and the continental plate. The oceanic plate is denser than the continental plate. So based on this, we have 7 major plates and some of the minor plates. So the 7 major plates are, what are the 7 major plates? Now looking at this diagram here in front of you, there are one of the 7 major plates are North American plate. What is North American plate? Is it an oceanic plate or a continental plate? It is largely a continental plate. We have South American plate, again largely a continental plate, but again both it has both continental part and the oceanic part. Third major plate is the African plate. Fourth major plate is the Eurasian plate, largely you can see dominated by the continents. Fifth major plate is Indo-Australian plate. In this diagram, Indian plate is divided and Australian plate and Indian plate are shown separately, but you can call it as an Indo-Australian plate, that it is a single plate, that is an Indo-Australian plate, or we can say that based on that it is divided further, can be divided into Indian plate and the Australian plate. And Antarctica plate, and lastly the Pacific plates. One of the best examples of why we took Eurasian plate as an best example of an continental plate, and why we took Pacific plate as a best example of an oceanic plate, because it can be seen in the diagram that Eurasian plate is mostly made up of continent, while the Pacific plate is mostly made up of an ocean. So the 7 major plates are: 1. North American plate, Second, South American plate. Eurasian plate. Pacific plate. African plate. Antarctic plate. And lastly, Indo-Australian plate. Now some of the plates are not major plates, they are known as minor plates. You remember the name of 7 major plates because maybe you can get a question in the preliminary examination asking you to choose one odd one out, or giving an option which of the following comes in the major plate category, which of the following comes in the minor plate category. So based on this we have the 7 major plates, while the minor plates are one of the most important minor plate is Cocos plate. Now you see the location of a Cocos plate marked by the blue color in the map. It is between the Pacific plate and the North American plate. So minor plates are Cocos plate, between Central America, will better write it as Central America, and Pacific plate, 2 major plates. Nazca plate just below the Cocos plate, between South America and Pacific plate. Philippines plate, come to the Pacific Ocean. The third important plate is the Philippines plate. It is between which 2 plates? Asiatic plate or Eurasian plate and the Pacific plate. Fourth important plate is Arabian plate. Fifth important minor plate is Scotia plate or Scotia plate. Where it is located? It is located between the southern tip of South Atlantic and Southern Ocean, or between or Antarctic plate. Or we can say between the southern tip of South American plate and Atlantic plate, or between Southern Ocean and at the boundary of a Southern Ocean and South Atlantic Ocean. So these are the important minor plates. Again, Cocos plate, Nazca plate, Philippines plate, Arabian plate and Scotia plate. Why they are important? Between this Cocos plate, we have Rockies mountain system, Andes mountain system surrounding the Nazca plate. We have the most deepest part on the earth near the tri-junction of Philippine plate, Pacific plate and this plate, Asiatic plate, that is the Java Trench, Arabian plate because that it covers the Saudi Arabia region and the Scotia plate. So remember the location, remember the names of these minor plates. So based on this, the theory of the plate tectonics says that whatever the changes which occur along the plates, it occurs, or whatever the changes which occur along the plate, on the continents or on the ocean or on the surface of the occurs along the plate boundaries. So whatever this, all these plates have been moving and they will continue to move in future. These movements cause different kind of tectonic activities, and these tectonic activities are largely concentrated on the boundaries of the plate, and therefore we study the different types of boundaries of the plate. These movements cause tectonic activities along the margins of the plates, and based on this, the boundaries or margins are divided into transform plate boundary, divergent plate boundary and the convergent plate boundary. So based on the different boundaries, based on the different kind of movement, we have three kind of plate boundaries, that is either transform plate boundary, divergent plate boundary and convergent plate boundary. As you can see in the first diagram, how is the transform plate boundary? You see in the transform plate boundary, the plates are sliding past each other. They are not moving towards each other, they are not moving away from each other, they are just sliding past each other, or we can say they are gliding past each other. In the divergent plate boundary, what we have studied already in the sea floor spreading, they move away from each other, that is there is opening up of the crust of the earth. And in the convergent plate boundary, they come together near each other, and because one plate is generally denser than the other plate, the denser plate goes below the lighter plate. In this way, we have different plate boundaries and different kind of geomorphic land evolution, different kind of relief features on the surface of the earth. And so the types of the plate boundaries can be divided into transform, divergent and convergent plate boundaries. These diagrams are simple enough to be drawn in the examination. Now we will study each and every plate boundary in detail. First, starting with the divergent plate boundary. The divergent plate boundary is also known by the different name as a constructive plate boundary. So here the two plates, we can say it is also known as a divergent or a constructive plate boundary. Now already we have studied in the sea floor spreading, what happens in this kind of a plate boundary is the two plates, they move away from each other. Because they are moving away from each other, the molten rock material, that is magma or lava, which is below the surface of the earth, it rises upwards. So the movement of the plates away from each other causes an upwelling of magma or lava from the asthenosphere below. this molten rock material comes up and gets solidified. So these divergent plate boundaries are associated obviously with volcanic eruption, with the seafloor spreading. So what you see here in the first diagram, the plates are moving away from each other. Because of the plates moving away from each other, the molten rock material rises upwards and forms a boundary. Further movement of this molten rock material away from each other will result into new lava or magma, which will rise upwards and it will settle down. Again, a new lava or magma will keep on rising and it will keep on settling down. As a result of this, we can see that there is a formation of, in this kind of a plate boundary, there is a kind of an volcanic eruption, there is a formation of, they are associated with mid-oceanic ridges on both the sides of the ocean floor. So what is this divergent or constructive plate boundary? Why it is known as the word constructive now? Why the word constructive is being utilized? See, it is being utilized because there is a construction of the Earth's crust here. How there is a construction of the Earth's crust? The molten rock material is coming from below and it is forming solid crust. Because of the solidification and cooling, it gets solidified, formation of a hot basaltic crust. So that is why it creates the crust on the surface of the earth, and hence it is known as a constructive plate boundary. There is no destruction of the earth's crust, unlike at the other plate boundary which you will see here. There is a creation of the crust of the earth, or creation of the rocks on the surface of the earth, or creation of the igneous rock on the surface of the earth, which was the first rock to be created, and hence it is known as a constructive plate boundary because of the creation of an feature known as mid-oceanic ridge. So what is this divergent or a constructive plate boundary? Here the plates move away from each other. Because they move away from each other, there is a continuous upwelling of molten rock. There is a continuous upwelling of a molten rock which forms new oceanic crust. Because it forms new oceanic crust, therefore it is also known as constructive plate boundary. Now you see what are the features which will be associated with this constructive plate boundary. This constructive plate boundary will be associated with, first, mid-oceanic ridges. They will be associated with the mid-oceanic ridges. They will be also associated with continuous volcanic eruption. Now what will be the nature of this eruption? The nature of this eruption, see in the second diagram, because the earth's crust is moving away from each other, the topmost layer, that is the earth's crust, because it is moving away from each other, the molten rock material or magma does not have to force its way up. The earth's crust opens and the molten rock material or magma easily finds a way to come out from the below. And as a result of this, the volcanic eruption associated here is a silent kind of an volcanic eruption, where there is a continuous upwelling of a magma, as against the general idea of what we have an volcanic eruption, which is very violent blowing away of the top of the mountain. So they are associated with kind of a volcanic eruption known as fissure kind of an eruption. And thirdly, they are, whenever there is a volcanic eruption, whenever there is a sliding of the earth's surface, there are vibrations setting up on the surface of the earth, and these vibrations is the release of the energy, or these vibrations are known as earthquakes. So they will be associated with earthquakes. So the divergent or the constructive plate boundaries are the boundaries where the plate move away from each other. There is a continuous upwelling of a magma or lava, thus they are associated, and the formation of mid-oceanic ridges. Now this kind of a volcanic eruption is termed as a fissure kind of an eruption because there is already a fissure on the surface of the earth and the volcano comes out without any violent explosion. And whenever there is a movement of the surface of the earth, whenever there is a volcanic eruption, there is a release of energy and the vibrations are set up on the earth. Therefore, they are also associated with earthquakes. What are earthquakes? Basically, earthquakes are vibrations on the surface of the earth. So even if you are moving in a vehicle and if the vehicle suddenly dashes something, you will feel the vibration. Similarly, when the earth moves away, it glides, it does not glide without a friction. Obviously, there is some kind of a friction resulting into the earthquake. So the earthquakes are associated with the divergent or the constructive plate boundary. So these are the plate boundaries are constructive. Now where will be this plate boundaries? These plate boundaries will be along the oceanic floor. We have already done this concept in the seafloor spreading. The next important type of a plate boundary is a convergent or destructive type of a plate boundary. See, the name here suggests that it is a convergent, that is coming together, and it is a destructive because something is being destroyed in this plate boundary. Now if you remember the seafloor spreading concept, we said that these two plates come together. When the two plates come together, the heavier plate or the denser plate will obviously go below the lighter plate. When that is, it goes below the lighter plate along a zone known as a subduction zone. Whenever there is this kind of a movement which is together is known as convergence, and there is a collision of the plates here rather than divergence. So there is a coming of collision of the plates. In this collision, the sediments of the plates or the different kinds of plates are folded, and one of the lighter plate goes below the heavier plate goes below the lighter plate. When it goes below the lighter plate, this area is known as the oceanic trench or the subduction zone. When it goes, it keeps on going below, and when it reaches into the mantle, due to the high heat in the mantle, it breaks down and it is again melted into the mantle and the vapors start rising up. So the convergent plate boundary the crust which is created in the divergent plate boundary is destroyed in the convergent plate boundary, and hence it is known as a destructive plate boundary. Now look at the diagrams here. In this there is a coming together of two kinds of an plate boundaries. When they come together, the kind of a motion is they're coming together. When they come together, consider this blank plate as an continental plate or the lighter plate, while we'll use a different color to determine the oceanic plate or the heavier plate. When they come together, there is a collision of the two plates, and as a result of this collision, there is a bending up or folding up of the sediments due to this collision. Due to this collision, the sediments of this both the plates are folded or intensely compressed, while at the same time the lighter plate rides upwards while the heavier plate goes below. Its also sediments are folded while the heavier plate goes below deep inside the mantle, and as a result of this there is a formation of two major relief features. Now you see what are these relief features. This relief features, the folded sediments gives rise to fold mountains, or they give rise to the mountain systems, while this area where there is a subduction occurring, that is what is subduction zone, an area where the denser plate goes below the lighter plate. Area where the denser plate goes below the lighter plate, represented by the oceanic trenches, where these are areas of what have I said, oceanic trenches. Now this plate which goes below this denser plate which goes below, where after going deep inside the mantle it is broken down, and after going into the mantle this broken down plate is melted, and due to the high heat present in the mantle. You remember that this is a mantle region, this is a region of asthenosphere, which we have not obviously shown in the diagram. After going down deep inside the mantle it gets broken down, because it gets sucked into the mantle, it gets broken down, and after breaking down it gets melted, and due to melting again the convectional currents rise upwards. When these convectional currents rise upwards, they take this molten rock material, this take different type of gases along with them, and when they come up with such a great, they are resisted by the great mountains, and because they have to escape, the energy has to escape, they blow away the top of this mountains, resulting into formation of violent volcanic eruptions, what we call as a volcanic mountains. Having violent volcanic eruptions. So here the crust of the earth is destroyed, and here there are violent volcanic eruptions. Remember, in our previous diagram, the plate here moves on its own. Because it is moving on its own, the magma or the molten rock material does not have to force its way out. It comes out easily, resulting into very simple or very silent volcanic eruptions known as fissure kind of volcanoes, which are not volcanic mountains but of a lesser height. While in this diagram we will see that because the oceanic plate is destroyed here, the oceanic plate goes below, gets destroyed. After destroying, the molten rock material rises upwards due to high heat, like vapors, and along with the vapors, gases, different kind of a molten rock material comes up. While coming up, it has to blow away the rock, continental rock, which is in between, and it has to come out, it has to blow the top of a mountain. So as a result of this, there is a high rock there is a heavier rock surface associated here. Now to blow away this heavier rock surface, there is a continuous collection of this molten rock material. After this continuous collection, the pressure builds up enough and the top of the mountain is blown away, resulting into violent volcanic eruptions. So the convergent or destructive plate boundaries are the plate boundaries where the two plates come near each other. Because the two plates are coming near each other, the two plates come near each other. When the two plates come near each other, the denser plate, consider this paper as a denser plate, goes below the lighter plate, that is the plane. When it is going below the lighter plate, there is a folding up of the materials on or the sediments on the plate. When there is a continuous folding up of these materials or sediments, obviously the sediments or the deposits from both the plates are folded, giving rise to the mountains. As a result of this, the plate further goes below. When it further goes deep inside the mantle, this plate is broken away. After breaking away, there are mountains here. The magma rises up and it blows the top of the mountains violently to form violent volcanic eruptions. So the convergent or convergent plate boundaries are associated with destruction of an oceanic crust. They are associated with here violent volcanic eruptions. They are associated with the tallest and the most loftiest mountain systems because they are formed by extreme crustal bending of the sediments. Then here what happens here in this kind of a volcanic eruption, in this kind of a plate boundaries, the two plates come near each other. Because they come near each other, there is a collision. Due to collision, the lighter plate rides upwards, while the heavier plate goes below. The lighter plate rides upwards while the heavier plates goes it goes below at a point known as subduction zone, which are represented by oceanic trenches. The sediments are folded to give rise to fold mountains. The sediments are folded to give rise to the fold mountains. Now, due to the due to the going down of the heavier plate after going down, it is destroyed into the mantle, and because of the destruction, the fumes rise upwards, and they are also associated with volcanic eruption. The heavier plate after being subducted into mantle is destroyed. What are these plate boundaries associated with? First, they are associated with fold mountains. Second, they are associated with violent volcanic eruptions. Third, they are associated with oceanic trenches. Fourth, they are associated with destruction of crust. And obviously, whenever there is, as we done, whenever there is volcanic eruption, whenever there is a collision, obviously there will be vibrations, so they are associated with earthquakes. So they are associated with earthquakes. So these are the convergent or destructive plate boundaries. Now, coming together of the plates resulting into formation of fold mountains. See the location of any fold mountain in the world, it is due to the convergence of two plates. They are associated with violent volcanic eruptions. In the areas of fold mountains, they have history of volcanic eruptions, except for Himalayas. Why it is? We'll do it in Indian geography. They are surrounded by oceanic trenches. There is a destruction of the crust, and hence it is known as destructive plate boundary. And obviously they are also associated with earthquakes, which also happens in the Himalayas, because Himalaya is an example of a convergence of Eurasian plate along with the Indian plate. So the convergent or a destructive plate boundary, what are the examples? Examples are first the Rockies or the Andes mountain system of South America. See, these mountains are due to the convergence of Pacific plate, Nazca plate, Cocos plate, and as a result of this, you see one plate is an oceanic plate, while one plate is a continental plate. And hence there is a going below of oceanic plate below the continental plate, and therefore these are associated, these are the earthquake as the volcanic prone regions of the world. There are numerous of volcanic eruptions here. Also they have parallel trench, for example Peruvian trench here. What does the Peruvian trench show? That is the plate, oceanic plate is going below the continental plate. Again, an example of Indian plate. Is an example, Himalayas are the example of collision of Indian plate along with the Eurasian plate. That is Europe and Asia plate. And Indian plate. But this is a typical example of a continent-continent collision, and as a result of this, there is no volcanic eruption, because in the continent-continent collision, both of them being belonging to the same density, there is no subduction of a plate into the mantle. So these are the two examples, that is the Himalayan mountain system formed here in this area of collision because of the Indian plate along with the Eurasian plate, and also the Andes and the Rockies. These are the young fold mountains of the world. These are the highest mountain systems of the world, formed due to the examples of convergent or a destructive plate boundary. So remember, they are associated with violent volcanic eruptions, they are associated with earthquakes, they are associated with fold mountains, and they are surrounded there, that is they are associated with the oceanic trenches which lie parallel to these mountains. Now the third kind of a boundary here is a transform or a conservative plate boundary. Now this is a very interesting plate boundary when the two plates, rather than coming towards each other, they slide across each other. That is, there is no coming together of the plates, there is no moving away of the plates. The plates slide past each other, and as a result, because the plates slide past each other, there is no creation nor destruction of the crust. Why there is no creation? For creation of the crust, the earth has to move away. For the destruction of the crust has to go inside the mantle and get destroyed. But when they are going parallel to each other, when they are sliding past each other, there is no creation, neither destruction. And therefore, there is a conservation of the earth crust. Therefore, they are known as conservative plate boundaries. Now in this conservative plate boundaries, the plates just slide past each other. So as a result of this, there will be upwelling of a magma? Will there be a volcanic eruption when they are sliding past each other? See, whenever for volcanic eruption to occur, the plate has to go inside the mantle. For volcanic eruption has to occur, either the plate has to move away from each other, or the plate has to go deep inside the mantle, get destroyed, and then the lava has to rise up. When the plate is going past each other, then the plate is sliding past each other, the plate is neither going inside the mantle nor there is opening up of the earth. So as a result of this, the conservative plate boundaries are not associated with volcanic eruption. Will they be associated with mid-oceanic ridges? For creation of a mid-oceanic ridge, first the lava has to rise up, then cool down, then only there will be mid-oceanic ridge. So they are not associated with mid-oceanic ridge. Third, will they be associated with fold mountains? Though no, because the fold mountains are caused due to collision, head-on collision, compression, and then only fold mountains. So they are not associated with mountains. But then what is the importance? See, when the plates are going past each other, suppose you are traveling in a car or in a vehicle and some vehicle comes and brushes your vehicle, you will obviously feel the vibration, there will be some kind of a loss of balance. Same thing happens when the plates pass each other. This surface is as what we draw in the diagram. The surface of the earth is not smooth. Obviously there is lot of friction, and when the plates slides past each other, there occurs vibration, and they are associated, and therefore this transform plate boundaries are associated with earthquakes. They are associated with earthquakes, and that too powerful earthquakes. Why? Because there is a brushing past each other. So these are the three important types of plate boundaries which are there. So coming to again the plate tectonic theory. The plate tectonic theory talks of three types of boundaries, that is the transform boundary, divergent boundary, and the convergent boundary. What is a plate? The solid lithospheric slabs which glides past the asthenosphere, glides over the asthenosphere, are known as plates. Plates are divided into oceanic plate or into the continental plate. Oceanic plate has the dominance of ocean. Example is the Pacific plate here, while the continental plate has the dominance of a continent. Example is the Eurasian plate here. Some of the plates are very big and they are known as the major plates. The 7 major plates are Eurasian plate, African plate, North American plate, South American plate, Pacific plate, Asiatic plate, that is again Eurasian and Asiatic plate, and Indo-Australian plate and Antarctic plate, while some of them are minor plates. Whatever the movements, whatever the tectonic activities, they occur only on the boundaries of these plates, not in the middle. And hence the theory of the plate, what are the activities? Based on the movements, these activities will result into whether the fold mountain will be formed, whether a mid-Atlantic ridge will be formed, with what will be the height of a mountain, what will be the relief feature of a mountain, what will be the direction of a slope of the mountain, whether the area will be associated with earthquake, whether the area will be free from the problems of the earthquake, that is whether it will fall in the earthquake prone zone or whether it won't fall in the earthquake prone zone. It all can be explained by the theory of the plate tectonics based on the movements of the plates. These plate movements are classified into 3 types, and these are divergent plate boundaries. These plate movements are classified into 3 types, and they are transform movement, and hence we call it as a transform plate boundary. These are divergent plate boundary or divergent movement, and convergent plate boundary or the convergent plate movement. In the transform plate, there is neither creation nor destruction of the earth of the plate, but they are associated with powerful earthquakes. Here the plates just slide past each other. Example is, we will come to the example again, San Andreas fault. In California. USA. Divergent plate boundary, the plates move away from each other, therefore there is a creation of the earth's crust, and then therefore they are known as a constructive plate boundary. They are associated with mid-oceanic ridges. They are associated with fissure kind of a volcanic eruption. They are associated with earthquakes. Convergent plate boundary, here the plate is destroyed or the crust of the earth is destroyed. And therefore they are known as the destructive plate boundary. They are associated with violent volcanic eruptions. They are associated with fold mountains, that is one of the loftiest mountains in the world. They are associated with earthquakes. They are associated with marine or oceanic trenches, that is the deepest parts of the oceans. An example will do, the example of each of this. Now look at this figure, here you will understand how actually it looks in the real life. These three kind of the plate boundaries. See, these three kind of plate boundaries are shown. Now, first looking at the mid-oceanic ridge. Mid-oceanic ridge, you can see that the ocean floor spreading here, and it is associated with this kind of an plate boundary. That is, they are associated with the mid-oceanic ridges. This is an mid-oceanic ridge. I am marking as 1 in the figure. In fact, even now here there is a spreading up of the continents. Here there is a spreading up of the, not continents, Earth's crust. It is associated with rising up of the magma and forming up of the mid-oceanic ridge. And then you will see a new concept here, that is the concept of hotspot, marked by the label 2 in the diagram. What is this concept of an hotspot? This concept of an hotspot is the weaker zone of the earth where there is a continuous upwelling of the magma, or where there is continuous volcanic eruption. Now, why there is a continuous volcanic eruption? Because the crust here is weak, and therefore the molten rock material can steadily come. Now, you look here at the third marking in the figure, which is shown as a oceanic and continental collision. That is the kind of a boundary between ocean and continents. That is, it is an example of a destructive or convergent plate boundary, which is marked by an oceanic trench. The plate here goes below through what we call as a subducting zone near the oceanic trench. This trench is the deepest part of the ocean. After going below the subducting zone, it is destroyed after going into the mantle, and hence the lava rises upwards. After rising upwards, they blow away the top of a mountain associated with violent volcanic eruption. Hence, because violent volcanic eruption, therefore the lava does not flow for a longer distance, and they are associated with volcanic mountains. This entire area sediments are folded to form volcanic mountains, and because of the mountains, the kind of a volcanic eruption is violent, associated with smoke, associated with blowing away of the top of the mountains. On the other hand, here the kind of a volcano is shield volcano, which is not a volcanic mountain. We'll come to that concept in detail while doing the topic of volcanoes. Now, you see here in between these two boundaries, here this area which I am marking by red color in the ink, there is a transform plate boundary. Why it is a transform plate boundary? Because this plate is moving in the opposite direction, in this direction, while the second plate is again moving in different direction. Now you see this area here, it gives rise to a transform plate boundary in this region. In this region, it is not associated with any kind of ridge, any kind of volcanic eruption, but they will be associated with obviously with very, very powerful earthquakes. Now, this transform plate boundaries, here in this diagram, we are showing this in the ocean, but they are also associated with, as I said, gave you an example, on the land surface. In USA, the San Andreas fault system of California is the best example of a transform plate boundary, where one plate moves in one direction while the other plate moves in the opposite direction, as is shown in the figure here. resulting into formation of a fault system or an example, perfect example of a transform plate boundary on the continent. Now, you see in the real life, the transform plate boundary will look somewhat like a gap or somewhat like a fault in the Earth's surface. Now see here, there is no creation of a crust, no destruction of a crust because of the movement of the plate in opposite direction. But obviously, there will be a very, very heavy earthquake. So you remember from the exam point of view, California's San Andreas fault system is an example of a conservative plate boundary. Mid-Atlantic ridge or any kind of mid-oceanic ridge is an example of a divergent or constructive plate boundary. While any kind of a fold mountains what are the major young fold mountains? Alps of Europe, Himalayas, India, Andes, South America, Rockies of North America, these all are the examples of convergent, that is coming together, or destructive plate boundary. So this explains our theory of plate tectonics. What is accepted as a force? The convectional currents which arise from inside the earth have been accepted as a force for the plate movements. So these are the different types of theories of the plate tectonics. Now, two important concepts while dealing with the plate tectonics, while we'll deal with the theory of the plate tectonics, is one concept is of the Pacific Ring of Fire and the other concept is of the Himalayas system. Just for an example, you should know what are this, or they also have a capacity to be asked as a separate question. See, what is this Pacific Ring of Fire? Now, surrounding the Pacific Ocean, if you remember this first diagram in which we have shown the two different kinds of surrounding the Pacific Ocean, here there are different kinds of plate boundaries. Now, if we try to draw this in the diagram, the area which surrounds the Pacific Ocean will look somewhat like this, shown by North America and South America, and here Eurasia. Now here it is an area, that is, we already have done that this central part, that this Pacific Ocean is an example of a contracting ocean. Why it is an example of a contracting ocean? Because of the coming together of many different kinds of plates. Now here this North American plate is coming towards the Pacific plate, South American plate is coming towards the Pacific plate. Here also the plates are expanding, and as a result of this, the Pacific Ocean is being contracted. Due to this, there is along this boundary, along the Pacific Ocean, this is an example of a destructive or convergent plate boundary. And because it is an example of a destructive or a convergent plate boundary, there is a continuous volcanic eruption. There is a continuous, this is an area of a fold mountains. New Zealand is famous for mountains. The area Japan here, Philippines, even this is famous for mountains. In fact, this area has the deepest trench that is known as Marina Trench here in this region. Here, the Japanese islands are famous for this. Japanese is mostly 80% mountain country. Similarly, Rocky Mountain System and the Andes Mountain System. In fact, the highest volcanic mountains of the world are located in the Andes Mountain. This is the second highest. These are the second highest mountains after Himalayas, but the highest volcanic mountains, because the Himalayas do not have presence of volcanoes. Why the Himalayas do not have volcanoes? We'll come to it in the later part. Now, this entire area is represented by destructive or convergent plate boundary, where the two plates converge, and as a result of this, this area is one of the tectonically most active area. Due to tectonically being most active area, there is continuous volcanic eruption, continuous mountain building, continuous earthquake in this region, and hence this region is known as Pacific Ring of Fire. If you look into the diagram, it will look like this. So you see this entire region here, this Pacific region is an example, this entire region here is an example of a convergent plate boundary, resulting into form continuous, that is destructive or convergent plate boundary. Most active tectonically, and because it has most active, it has a concentration of volcanoes and earthquakes, and therefore this area, due to continuous volcanic eruption, is known as Pacific Ring of Fire. Now coming to India and the plate tectonics. Now we know that Indian plate, if we look at the distribution of India today, how is our country? When we draw a diagram of our country, we draw our country is this is the rough sketch of India. That is the peninsular part of India and the Himalayan part of India. If we take a cross section of India, the cross section of India will look like this: the three ranges of Himalayas, then the Great Plains of India, the Great Plains of India being filled by sediments, then the plateau region and the coastal plains. So we have Himalayan region, we have plains, we have plateau, and we have coastal plains. See, this part of India is an example of an Indian, or was a part of a Gondwana land. While this part, the Himalayan part or the upper part, when we say upper part, it was in a part of an Eurasia. So that means somewhere in between the history of the earth, India traveled, separated from the Gondwana land, traveled over a large distance, came and collided with the Eurasian plate, which is present here, resulting into formation of Himalayas in the areas of collision. So the Himalayan mountains are the examples of continent-continent collision due to, or we can say, the Himalayan mountain system is an example of continent-continent collision. Why? Because Indian plate was a continental plate, Eurasian plate was a continental plate. Between Eurasian plate and Indian plate. Now, due to it being a continent-continent collision, both these plates were of somewhat of a similar kind of an, we can say, density, though the Indian plate was of an higher density as compared to the Eurasian plate. So when the Indian plate came near the Eurasian plate, the Indian plate did not go too much below the Eurasian, too much deep inside the mantle or below the Asian plate. But there was, due to extreme collision, there was high folding of the sediments from both the plates. But the Indian plate did not go deep inside the mantle. And as a result of this, the Himalayan mountain system which was formed here, as the Indian plate did not get subducted into the mantle, the Himalayan mountain system do not have volcanoes. But obviously they are associated with dangerous earthquakes. Now the greatest height of the Himalayan mountain system is due to the phenomena known as doubling up of the crust. Why doubling up of the crust occurred here? In the normal conditions, that is in the conditions during in the Andes mountain system, in the Rockies mountain system, the oceanic plate went below the continental plate, it got destroyed in the mantle. But in the case of India, in the case of Himalayas, the Indian plate did not go deep inside the mantle and therefore did not get destroyed. But there was a doubling up of the crust resulting into greater height of the Himalayas. The Indian plate was located, as we know, somewhere near in the southern pole. It traveled towards the north, and then it came and collided collided with the Himalayas. Now, when it was traveling to the north, it passed over an hotspot. It passed over an hotspot which was known as Reunion hotspot. What I told you in the hotspot is the area where there is a continuous volcanic eruption. It passed over an hotspot known as Reunion hotspot. And because it passed over an Reunion hotspot, we have volcanic eruption which is represented by Deccan lava plateau. This part of India, that is the Deccan Plateau region, which is represented by black cotton soil or black soil. Why the soil is black in color? Because of the presence of basaltic rock system. So while passing over the Reunion hotspot, it underwent an volcanic eruption, and roughly around 60 million years ago it underwent an volcanic eruption, and which is represented by the Deccan Traps. And then further it went and collided with the Himalayan mountain system. It collided with the Eurasian plate, resulting into the formation of Himalayan mountain system in this region. Now you see, initially the India had two arms which were extended by the Aravalli mountain system and by the mountains of North India. We could do it in detail. Now if you look at the map of India, we have Aravallis here, we have northeast mountains here, we have Himalayas in this region, we have the Deccan lava plateau in this region. Now the two arms give a maximum push to the Eurasian plate, and as a result of this, the there is a sagging down of the Himalayas in between. Himalayas are not in a straight line, but they are sagging down, and there are two hairpin bends in the Himalayas due to the maximum push offered by the Indian plate towards the Eurasian plate. So the middle portion of the Himalayas sags down, while here there are two hairpin bends in the Himalayan region due to the maximum push. So this is the concept of India and plate tectonics. To see it properly in the diagram, you can see here that the Indian landmass was initially in the southern hemisphere. It passed over, it started drifting due to the continental drift theory. As is explained, it started drifting towards the north, and as a result of which Indian Ocean occurred. Somewhere around 60 million years ago, it passed over a Reunion hotspot, resulting into volcanic eruption and hence formation of a Deccan lava plateau or black cotton soil. Then it further went here, and finally it came and collided with the Himalaya, with the Eurasian plate. It is an example of a continent-continent collision. Due to the collision of an Asian plate, the two arms of the Indian plate extended a maximum pull, and hence the Himalayan mountain system were formed, but they have an hairpin bend like this because of the extension of the two arms. Because there was no major mountain system in between, therefore the Himalayas sag downwards in between. It can be also seen in this diagram here, that is, whenever the Indian plate is moving towards the Asiatic plate, at the same time here there is an example of a destructive plate boundary, while there is here the mid-oceanic ridge is opening, which is an example of an constructive plate boundary. So we have the Himalayas mountain system here, and exactly down here in this we have a mid-oceanic ridge. So again it can be explained by the seafloor spreading, is in fact validated more by the plate tectonic theory. Now the plate tectonic theory also can explain why there is a lack of volcanoes in the Himalayas. Why? Because it is an example, as you see in the diagram here, it is an example of a continent and continent collision, not an example of an oceanic and continental collision. And as a result, because it is not an oceanic and continental collision, none of the crust is destroyed. Second, though there is a collision here, also at same time parallel down, there is a presence of mid-oceanic ridge, and the seafloor spreading is occurring below the Indian Ocean. The Indian plate is still going below the Asiatic plate, and therefore the height of Himalayas is still increasing. Why? Because the Indian plate is still going below the Asian plate, and thus whenever there is a vibration, whenever the Indian plate slides downwards, goes below the ocean plate, below the Asian plate, there is a earthquake here. Recent example is a Nepal earthquake. Why? Because of the movement of the Indian plate below the Asian plate. So this is how you can relate the geography, relate the plate tectonics, and thus how the plate tectonics explains the most of the major phenomena on the surface of the earth, that why there is a presence of mountain system, why there is a presence of volcanoes, why there is a presence of mid-oceanic ridge. Now for the exam point of view, the kind of questions here can be based on the plate tectonics. The questions here can be: explain the plate tectonic theory, second can be: how does the plate tectonic theory explain mountains across the world. Third question can be, explain formation of Himalayas. As per plate tectonic theory, allow me to use the shortcut here. PTT means the plate tectonic theory. Similarly, Andes Rockies mountain system. Then from the prelim point of view, you have to remember that different kind of plate boundaries. And features associated. You have to remember different types of plates and their movements. What I have given you an example, they are sufficient. Now to remember for example, oceans, that is Atlantic Ocean is an example of an expanding ocean. Indian Ocean is also an example again of an expanding ocean. Pacific Ocean is an example of an contracting ocean. What is known as ring of fire? This concept again we will do it in detail in the volcanoes and earthquakes. So this explains the plate tectonic theory. So here we will stop with the plate tectonic theory in this, and the next will be the movement of the which are found on the surface of the earth. So thank you very much.